Okay, Bismillahirrahmanirrahim. We start our class today with chapter 3, introduction to Z formal specification language. Okay, for this one, it's normally said as a Z notation, Z notation, ZED, Z notation. Okay, this one, Z notation or Z as specification language. Is a formal specification language that has been used for describing and modeling computer system. Okay, this one describing. It is the targeted at clear specification of computer program and computer-based system in general. Okay, and then a formal specification notation based on the set of theory. And then for the Z as specification language has been developed by the programming research group in the late 1970s. Most probably now is the most widely used specification language. Okay, and then this one in history in 1974, John Raymond Abreu published a paper named it as a data semantic. He used a notation that would be later be taught in the University of Grenoble until the end of 1980s. Okay, and then Abreu also wrote internal notes on Z. Okay, some of the Z notation is used in the 1980 books methods deprogrammation. Okay, and then Z is this one is history, little bit of history. Yeah. John Raymond Abreu. Okay, and then this one John Abreu has said that Z is named because it is ultimate language. Uh, okay, and then Z here we take from the word Zermelo. Zermelo is used through its Zermelo-Frankel set theory. Okay, and then Z is based on the standard mathematical notation used in axiomatic set theory, lambda calculus, and first-order predicate logic. Okay, and then for Z specification are built from the component called schema. Later we see the schema, but Z itself is based on the standard mathematical notation. Okay, mathematic set theory. Okay. And then we have first order predicate logic. And then we have lambda calculus. Okay, boleh baca? Can you read my handwritten? Okay, so far, do you have any question? Okay, and then this one is for Z notation symbol. Basically, we use schema. Schema are the specification built-in blocks that use the graphical representation. And then the mathematical notation schema that uh, allows the building of formal completeness and consistency, proof to validate the specification. Okay, and then for the Z schema introduced by the entities. And then first we see here is a predicate is a Boolean expression. Some predicates can have a side effect that change the state of the entities involved. This one include the pre and post condition. Schema can be included in other schema and may act as a type definition. This one you can integrate. Okay, and then we have names. Names are local to schema in many respects. Z schema are akin to object. This one is similarly to object. Where do you use the uh, KZ notation is basically is computer program and computer based system in general. Okay, this one is problem storage tank monitoring system. A storage tank is monitored by a control system. The system consists of container that hold something and an indicator panel that show the current field and the danger level. It has two stick here, field level and danger level. And then if the storage tank goes over the danger level, okay, we have a storage tank danger level. Okay, a warning light must be lighted on the indicator panel. So the field operation must be specified as to ensure the tank to be refilled but never overfill, never overload. So in a Z notation, we have a container specification. Okay, first here, this one is a container. Container is a schema name, and then we have a schema variable declaration. Okay, as natural numbers. Okay, we have natural numbers here, and then we have schema predicates. Okay, schema is used to structure. The schema is used to structure and compose mathematical description, collating pieces of information and encapsulating them and naming them for the reuse purpose. Okay. Schema language. Okay. And then we have schema name, a schema variable declaration, and schema predicates. Okay, for example, we have declaration and constraint. In any mathematical description will involve declaration of identifier and constraint upon them. In formal specification, group of identifier may be used to describe a component or compound object or related properties. Okay, we have example. We have example. Uh, okay, schema is a pattern of the declaration. Okay, this one include okay for the schema. Okay, normally when you name as notation, we have for the schema we have a declaration and constraint. Constraint. Okay, or in a vertical form, you can represent this one in vertical form. Okay, by the declaration constraint. Okay, in vertical form, we may align the semicolon between declaration and conjunction between the predicates. Unit declaration, for example, this one, you need to have the semicolons. Okay, semicolon like this. Okay, ada soalan ke? Syed Nizamuddin, okay ya? Hafiz? Okay, for naming the schema, we may give a name to schema and use the name to refer the corresponding pattern or declaration, and also for the constraint lah. Definition is name uh, equivalent to exp, which must be a schema expression. Okay, we have name here, exp lah. Exp is a schema expression. This one exp schema expression. Okay. Okay, here name schema name. Here we name it as a container. Container. Okay, and then expression we have content. This one in the horizontal form. This one in horizontal. This one in the vertical. Okay, in a final assessment, you need to answer the question in the vertical forms. Okay, normally we use the vertical other than horizontal. Okay, ada soalan ke? Do you have any question so far? Akil, okay. Okay, the schema names the schema includes the name. First one, identifying the schema. Secondly, we have signature. Thirdly, we have predicate. Huh? Okay, name is identifying the schema by describing the expression. And then signature is introducing entities and their types. Huh? Okay, we have entity and their data types. And then a predicate part defining the relationship, okay, between the entities in the signature by starting a logical expression which must always be true lah. Okay, or we name it as invariant. Okay, invariant in formal method. Invariant informal method. We describe invariant informal method is a condition or state that a property that does not change as a loop execute. This one more on the state of property. Uh, okay, ada soalan ke sekarang ni? Do you have any question? Okay, this one is example. This one is schema name, and then we have light the condition. The condition. Okay, light on, off, or on, and then we have reading separated the state separated by semicolon is natural numbers. Okay, and then we have place of declaration and a place of predicate. Place for predicates. Okay, and then okay, this one declaration. Okay, we have declaration. Declaration. Okay, declaration, and then we have a predicate. Okay, here is the declaration. Okay, if the storage tank goes over the danger level, a warning light must be lighted on the indicator panel. Okay, light on, equivalence to reading, equivalence reading, and then we have reading is greater than or equal to danger level. Okay, do you have any question? Ada soalan ke? Okay, equivalence. What is equivalence mean? Equivalence mean that two schema are said to be equivalent if they declare the same set of identifiers which have the same type and impose logically equivalent constraint upon them. Okay, we have equivalence. Boleh baca ke tulisan saya? Okay, and then we have a storage tank. We have container indicator, and then reading equal to content capacity. This one is the reading, and then the level is 245,000. Okay, and then the content is n, natural number, capacity, reading n, danger level n, and then we have light on, and then we have content is less than or equal to capacity. Okay, and then we have light on is equivalent to reading. Then reading equal to content, capacity equal to 20 250,000, and then danger level equivalent to 245,000. Okay, I think I should look. Okay, and then okay, this one is a schema name. Okay, we have continuation. Okay, we have storage tank, and then we have field okay, partial specification, partial specification of field operation. Okay, here you can see schema as a declaration. Okay, okay, and then we have field okay, and then we have delta. Okay, we have z and z and delta, z and delta. Okay, this one is Z convention and Z convention. Convention. We have input, uh, input. We declare as exclamation marks. Okay. Output. Okay. And then Z symbol like this. Z symbol. Okay, Z symbol means that the font, the schema name is not changed. And then for the delta, this one delta. Okay, it would mean that the schema name will change. This one will change. Okay, here if you see the storage amount is changed. Okay, it's changed based on the amount. This one is input. Okay, the question mark is the input. Then the output is the exclamation marks. Okay, any question? Do you have any question? Okay, clear. Kalau ada soalan boleh tanya lah. Okay, and then we have the predicate content plus content as an input, less than or equal to capacity, and then content. Okay, okay, we use the invariant after. This one we name it as invariant after. What is invariant after? Invariant after is the state before and after the operation. This one is after the operation. Okay, boleh? Okay, in here we expect that the set of contents known to the system will be augmented with the new name. So we put the what we call it as apa tu nama dia? Single mark What? Double mark. Double single quotation Okay. Is invariant after lah. Okay, Ahmad Aiman, what is invariant mean? Invariant tu apa maksud dia? Ahmad Aiman, invariant tu apa maksud dia? Ha, tu kan saya dah terangkan tadi invariant. Kamu tak salin ni? Dah masuk lambat. Kenapa masuk lambat? Kan dah tinggal. Oh, kamu tidur lah. Cakap lah kamu tidur. Aduh. Kamu bagi tahu dia punya apa invariant after, kamu bagi invariant before. Saya nak invariant after. Okay, Nur Izian, apa maksud invariant? Nur Izian, ada ke Nur Izian Hanani? Apa maksud invariant tadi? Tak sempat tangkap. Ni. State, we can declare as a state a property does not change as the loop execute. This one invariant. Okay, and then schema name prefix by the Greek letter delta. This one I have explained. Mean that the operation change the sum of all of the state variable introduced in that schema. The input name decorated with a question mark, and then name decorated with a quote mark, and it represent the value set and after the operation, or we can call it as invariant after. Okay, after the okay, after the operation. Okay. Okay, and then schema name prefixed by the Greek letter Z means that the defined operation does not change. The value of the state variable. This one is not changed, which means that same as the constant. And a variable name decorated with exclamation marks represent output. Input, I have explained input. We have question marks, and then output is exclamation marks. Okay, and then feel okay. We have Okay, we have storage tank and then amount as input, natural numbers. Okay, and then overfill. This one is third operation. We have Z storage tank amount, and then R exclamation mark as output. Sequence character, and then we have a predicate capacity less than content plus amount, and then R as input insufficient tank capacity minus a field cancel, and then we have a field uh, we have uh, or overfill. Okay, and then this one is full problems specification. We have a container, we have indicator, we have storage tank. We have fill okay, overfill and fill. We have how many operation here? One, two, three, four, five, six. Six operation. Okay, operation specification. Define the normal operation as a schema. Define schema for exceptional situation. Operation may be specified incrementally as a separate schema, or you can combine to produce the complete specification. Okay, and then combine all schema by using this junction, or written as all. This one is disjunction. Okay, this one is uh, the right naming convention. We have a name identifying the schema. This one is just recap. Delta mean changes. Z mean no changes. Question mark mean input. Uh, exclamation mark mean output. And then single quote represent the value of the variable after the operation, or we can call it as invariant. Okay, and then we have a symbol. We have and this one. We look predicate as a set. Before this, we look set as a predicate. Okay, this one as a set. Okay, you can declare either both by using set or z set, or you can have the predicate. Okay. Okay, we have a partial function, and then we have a total function. We have domain of f, we have range of f, and then we have extension function of definition. Okay, and then we have a negation, conjunction, disjunction, equivalent, and implication. Okay, key point. Z specification are made of mathematical model of system state and definition of operation on that state. Basically, by using computer system. Okay, and then specification is presented as a number of schema. Okay, we can have a partial or full function, full partial schema, uh, partial or full function, and then schema may be combined to make a new schema. And the operation are specified by defining the effect on the system state. Okay, we have state, and then operation may be specified incrementally. Okay, different schema can be combined to complete the specification. The notation used is very cryptic. Though great effort is made toward understandability, cryptic means that you need to understand certain symbols. Okay, this one is another example to track data dictionary specification. We have given set, name. We don't care about the representation. Okay, and then we have a type definition. This one by using set. Okay, we have a small square. Okay, you can look this one. Okay, so far, do you have any question? This one is example. We have a birthday book example. Okay. Okay. This one birthday book. We have a known P. Name birthday name is partial to date, which means that some of the name doesn't have date. And then we have known as a domain of birthday. Okay, the invariant is satisfied because birthday record date for exactly uh, we have names. We have names. Okay, and then we have birthday books, and then we have this one as a set. We declare the post condition as a set. Okay, this one is not a member. Okay, okay, you can look after this. Please take some note for this one. Okay, for specification completeness, solution to develop new schema to enable covering a special cases in some operation. And then we can combine new schema with existing one. The advantage is to provide incremental and modular description of specification, and then specification are more readable. Okay, okay, here is another example. Birthday, complete operation, and then here another example, date. Okay, okay, this one interlock system. Okay, please read this one. Later I upload to Padlet and my guru. Okay, so far do you have any question? If I like it.